merge sort, right? And you always have some sort of array. Correct? The array comes in, right? That's what you're passing. Okay. So, what was the whole idea on? What was the whole concept on merge sort? I'm looking for a specific phrase. What was the concept of merge sort? Divide and conquer, right? So, there are different ways to do it, but this is the way I'm going to suggest you do it. Left equals create left. Right is create right. Okay, and this should split it. And if for uneven, it will make a decision, right? I should say for odd, right? So if it's odd, this one probably has one more than that, right? That's okay. What next? So we divided, right? Now we got to conquer, right? What is the conquer thing going to? What are we going to do for conquer here? Yes, right? Would you say that again, please?
Call merge sort on both of those.
Sort left, merge, sort right. Now we're not quite, because we divided, and we're going to try to conquer here. Yeah.
If you kept doing that, wouldn't that be an infinite recursion?
No, because eventually you're going to get to the size of 1, right?
Where do you have to get test that? Where's that?
How about this? Yeah, so what kind of test should we put in here?
If ARR dot length is equal to 1.
ARR dot length. We need to return just, if it's 0 or 1, we just need to return, right?
Yeah.
Less than or equal to 1, right?
Yeah.
Return ARR. Okay, that's a good catch. All right, so what? So we divided. We're trying to conquer. What's the last thing we do? Return, merge, left, comma right. Okay. I know you're probably not going to enjoy this next part.
So the recursive calls equal something? Or wouldn't they just return to nothing?
Yeah.
Is that resetting left and right?
So I think a good question, dude. So so let me show you how we probably should do it. Return. I'm just going to make a suggestion. You can. This goes with what you're thinking. Merge. Merge sort. Left.
Merge sort right.
Merge sort. Plus merge sort, or just comma merge sort right. Does that sound okay?
Yeah, and then merge and return the whole array.
Is that okay? I probably totally messed up my head. Is that okay?
I think so. Oh yeah, you can get rid of those last three.
Okay. Okay. So if I had a computer, I could actually let me see if I can write this neat. Return, merge, sort.
Are we only going to have to do pseudocode, or are we actually going to have to do...
For this, only pseudocode. The code is too big. It's not a test.
Okay. We'll just have to memorize the pseudocode.
Or you can be smart and just understand it. I'm sorry. Okay, but that's not enough for you to get full points on your test. What else do we need to do for you to get full points on your test? Okay, so we need a merge, right? Left, on the right, and I'm going to say ret value. Okay. Equals I don't know how you do that in pseudocode. It's an array of some sort. All right, so what do we have to do here? This is to me, this is more complicated than this, isn't it?
Yep.
Yeah. So we need int L, that is an L. Int R equals 0, right? Int, I'm just going to pretend like that has an add. Okay, so, while, if you guys have ideas, tell me. I'm just going to go though, while left, let's see, while L is less than left dot length, okay? And R is less than right dot length, okay? So far so good? If L is less than left dot length and left sub L is less than what? Right dot length, right dot R, ret value dot add, I just made that up, left sub L plus plus. Okay, so we're just moving, so left, the left thing was smaller, right? So we're going to keep doing that. Else R is less than right. Not length. Actually, there's a bunch of just and right. So right. The R is less than left. L. Ret value. See how we're add right. So R plus plus. Actually, there's a bug in this. Anybody see it? So if one of them is already at the end, so you with me? Anybody know?
Exit the loop, wouldn't you?
What now?
You would exit the loop because it's an and, right? Should there be or?
Yeah. No.
At the loop? No?
I mean, you might be right, but we really need to put stuff here. If L equals left dot length, then we're going to, oh, I see what you're saying. Yeah. Let me do it like this. So I'm going to follow your idea. I'm going to do it like this. Or L equals left dot length. That means L is we're already at the end of left, right? All we have left is right. Or R equals right dot length. If you have anything close to that. So I talked about your handwriting. Now mine is pretty bad there too. So just all you have to do is just remember that you're going to go to the right, whichever is less, add to the ret return string. Okay, that's all you have to. That's the whole gist of merge. So you've got to have both of these in order to get full credit. Alex is scratching his head like he can't read my writing.
Nope.
It's fine. You haven't set this on the first task.
Did I?
Yeah,
Yeah.
the start pseudocode was on the first task.
Yeah.
You know what though? Half of you forgot the merge part of it. Half of you, I think, forgot merge, didn't you?
That's funny because you specifically said before the first test to remember the merge stuff, and how funny it was when people forgot the merge.
Did I say that was funny?
Yeah.
I should have said peculiar or ironic instead of funny.
I just think he's feeling your head.
What now?
I have a sinking feeling you're going to have to demerge sort again, because the first time I remember, the first test I kept hoping you wouldn't demerge sort. I'm like, I'll memorize everything other than merge sort. The hint if you do merge sort is very, very low.
So I like merge sorts. I like bubble sorts. So I like the Java code for bubble sorts because it's easy.
Yeah.
And I like the pseudocode for merge sorts because it's pretty easy. So those are the two I'm probably going to pick from because I think they're the easiest things to give you on a test.
Okay. Well,
All right. Yeah, right. Well, let us pick which ones we want to do.
Do you have this on your notes?
Yeah, this is all of my notes.
The handwriting is kind of...
Really?
Oh, that is.
You know, that is... Okay, I'm starting to get offended with this handwriting. So I'll put this on the web first as soon as I get that file. Walking Dead isn't on until October, so...
So we got all the time in the world tonight.
You do. You can just hammer it.
So is this,
You put the actual example here.
Just get the document.
You guys.
What? You're going to miss us.
I am, but I'll see you. Yeah, I will see you guys this summer. So how many of you, by the way, how many of you are eventually going to take processes? All right. I'm for sure not teaching in the fall, so maybe.
What's the code for your class of processes?
COP 4331. It's a really good class.
Did you change the class from book to something else?
POOS. Processes of Object-Oriented Software. Okay, so we're going to talk about recursion just a bit here. Before Robert picks on me a little bit more here. So when it comes down to it, what is recursion? Calling yourself.
Sorry, I had to cheat.
Okay, so that's the base definition of recursion, calling some function calling itself, right? So because that is so valuable, we use it a lot, and we have to have some rules though, otherwise. So this would do what to our program? And how long would it be before our program crashed? Stack Overflow, really quick. Okay. We could also, though, we could also do this function A calls function B, and this happens occasionally. Function B calls function A. Okay, that's still a form of recursion, although it's not what we usually do, but it's still a form of recursion. Okay, so problems. What are the potential problems? Okay, the biggest problem is the function never exits. So we have to have some conditions. And the main thing you need to remember is what are the first conditions in all of your recursion? So you need your base cases. And without base cases, nothing is going to work out. Base cases come first, then potential. Recursive calls. Look at those guys making a lot of noise. Okay. All right. Let's have an example that actually works. So, what should our base case be? So my base might be, say 5 to the third power, right? 5 would be my base, 3 would be the exponent. So I've got to have a base case, don't I? Right. So if exponent equals 0, what should I return if it equals 0?
Are we doing just for the positive exponents, or are we doing negative?
Yeah. Yeah, we're going to skip the whole.
First, do you return 0 or you return 1?
Oh, sorry, you're right. She told me 1 and I wrote 0. How funny is that? How ironic is that, I should say. Return base. Help me out here. What should I return now?
Power.
Oops.
Base.
Power base.
Exponent minus
So
1.
base isn't going to change. Exponent minus 1.
Times base.
Yep.
So you're saying base times, got it. Is that right? That's pretty hard to read. Okay, and so we did Fibonacci twice. We did it with the base, with dynamic programming, and we just did it with recursion. Let's go ahead and do a Fibonacci, just basic. Okay. What's the first thing you always have to do in recursion in base cases? What's our base case going to be? If val, I'm going to suggest less than or equal to 2. Does that work? So what should I return here? 1. Okay, now what do I return? What do I do now? Return. What do I return?
Fib val minus 1 plus fib val minus 2.
Dot val
Minus 1.
minus 1 plus
Val minus 2. No.
fib dot val minus 2. I think we don't have someone in this class named Val. She'd be upset. What are you saying about me? Okay, recursion. Let's see what else. All right, so let me just give you these other notes. And these I took right off of our slides.
Does that seem val minus 1 plus val minus 2?
Okay, so I actually took these right off of our slides, but I'm going to also upload this tonight. But I don't get a lot of nasty emails, right? So every recursion should have the following characteristics: simple base cases, which we have a solution to, right? A way of getting our problem closer to the base case. What did we do here to get our problem closer to the base case? Okay. And what did we do for power? Subtracted 1, right? A recursive call which passes the simple problem back into the method. Okay. Let's see. So remember our binary array search? Can we do that recursively? That would be ideal for recursive, right? Go to the middle that. Let's see. I just got the source code. Okay, what about flood fill? So what's the pseudocode for flood fill? Help me out here. Let's go ahead and see if we can come up with the pseudocode for flood fill. And this pseudocode actually, I put this up on the web course. This pseudocode kind of assumes a few things. It assumes we have a get pixel function. Assumes we have assumptions. We have a get pixel We have a set pixel. We have a start color. We have this is for flood fill. So those are assumptions that you can make for a flood fill, okay? That we have those. So let's see, I have two methods here. I have do flood fill. And I have flood fill. You know, sometimes we have something that sets everything up. Remember how in the binary search trees we had like a setup and then it actually called? Okay, so the do flood fill is kind of the setup. Start color, right? Start color. Since you guys are so quiet, this sounds like it's going to be a really good test question.
So I think we will need to know how to do flood fill.
What now?
We will need to know how to do flood fill.
I would recommend it if I were you.
I thought I got away with it after the homework.
You thought you got away with what?
I thought I didn't have to do it after the homework.
Who said that?
Myself.
Okay.
I don't know.
Okay. So the start color equals get pixel x comma y, right? And you guys wrote this code, so this is not like big news to you.
That's a long time ago.
If the start color equals the fill color, and I'll ask you what I should do. If the start color equals the fill color, what do I do? Yeah, see, you did remember stuff. And then the last thing I do is I call flood fill. Flood fill x, y, w, h, fill color, start color. And the idea is that whatever the start color is, I'm only going to draw on the start color, right? Okay, so that's the whole idea. X, Y, W, what's so funny? Okay. So we have a base case here, right? Here's our base case. If x is less than 0, or y is less than 0, or x is greater than equal to what? W, or y is greater than equal to h. What do I do then? Return, right? Okay, that's a base case, right? That means if it goes out of bounds, we're going to return.
Less than y not or y 0.
Huh? Okay, so if get pixel x, y does not equal start color, another base case, right? In other words, we're on a different color right now. We're no longer painting on start color. So what do we do when we're no longer painting on start color? Return, right? Because this is another base case. Okay? And this is where, like, I'd say at least 15 of you messed up before. Right? I wasn't looking at anybody on the front row.
On the flood field, the first if, what is the thing less than y? The yeah.
X less than 0, y less than 0, x greater than equal to w, y greater than equal to h. I am significantly challenged on these things tonight for whatever reason. So I already knows the answer to this. So I went to Epcot on Saturday. Guess who I saw at Epcot? One of your classmates.
Robert?
No, you know Saddam? The guy who sits on the... Does someone else work at Epcot besides him?
Oh, he does the fast pass.
No, he was doing the... What's the thing in the golf ball?
World Spaceship. Oh, Spaceship Earth.
He was doing the thing in the golf ball. So,
You guys chat?
what now?
You guys chat?
No, he was working actually. I could have chatted, but well, XX less than W and get pixel. Ah, crap. Sub XX comma Y equals start color. Remember, we're looking for start color. We want start color. That's what we're going to change. Set pixel. XX comma Y start color. Okay. Right equals XX XX plus plus. I have no idea where I got right from. It's probably something. And that's all you need to know.
That's it.
Don't you have the,
You have to step up and down.
there's no recursion.
So I like totally don't have it. I must not have copied. All right, help me finish up here. All right, so that's, we went that way, right?
Now you have to recur up, right? During the while.
I have to go left too, don't I? I have to go left too, don't I? So now I say, again, I have to say XX equals X, right? And I do this walking left, don't I? And then, so let me say left, running out of space here. So then what do? I say, I recursively call flood fill Y plus 1 and Y minus 1, right? So, oh my goodness, let me just put it up here. So, can I trust you for walking left here? It's just X minus minus?
Yeah.
Thank you. But then I need to recursively call flood fill. Crap. Really? I didn't even do that. Okay, all right, so crap. I did this, didn't I? Flood fill X, X, comma, Y minus 1.
Yeah.
Didn't I do this?
Yeah, we did.
W, H, fill,
Yeah.
start. Didn't I actually do that?
Yeah.
Didn't I also do this? Flood fill,
Y plus 1.
X, X, Y plus 1,
Yeah.
W, H, fill, start. You guys know this better than I do. And then so I walked right, then I had to walk left like this. X, X equals X minus 1. And I did this exact same thing with one exception. Instead of XX plus plus, I did minus minus, okay? Do I have to write that whole thing again? Copy and paste. So we have while, set pixel, recursive call to flood fill, recursive call to flood fill, and then X, X minus minus. And so that will be your flood fill.
But the set pixel is the fill color, not start color.
But I took both, though. What now?
The set pixel, you set fill color.
Man, I'm glad you're here. Did I get these right? Okay. All right. Like I have. So did you guys look at the pseudocode? The pseudocode online has that same mistake. Like nobody cares. Okay. See how much you guys look at my pseudocode. Yeah. The pseudocode, because actual code is going to be a lot longer. So just know the pseudocode. So the pseudocode is. Yeah. All right. Let me try to think. So the next thing is hash tables. You guys want me to do hash tables, or you want to knock off?
Knock off as in not run a test or not?
No. Hash tables not being on a test is not an option.
Do we have hash table set up like that?
That's not an option either. Oh. we can either go home right now and start again next week, or you want to just do the hash tables now, you guys?
Yeah.
Just keep closing.
Okay. So I actually don't have notes for hash tables, so no, it's okay. We should. So any mistakes I make, I'm sure you guys will catch that, right? So why do we even need a hash table? Anything at Hard Rock, really? So.
Ticket prices for Hard Rock, like $30 to $40.
Do we, let's do a linear hash. How do you add to a linear hash table? And we're just going to do pseudocode. I don't think there's no way I can ask you to do this on a test. So how do we add, let's say we have array. This is where our hash values are. So how do we take a string? So let's say insert array and string. Okay, so how do we insert that string into the hash table?
You gotta.
First we say hash value. This calc hash. String, right, like that so far, we good? By the way, did anybody in here still have a 0 on your hash assignment? Oh, yeah. I know half the class is coming to me about that. Then what? So look at array. Actually, array if array what? Sub hash value is what? What do we have to look for?
There's something in there.
I'm just going to say it because you might have a special value or you might have a null or whatever. So since it's just pseudo, we'll just say empty. So if it's empty, what do we do?
Put it in.
Put it in, right? Array sub hash val equals new data structure, whatever that is, substring, right? And we don't have any real specifics. So that's if it's empty. That's the easy case to put, right? Otherwise, what do we do? Okay, so there are two cases. So that array element is full, right? What are the two possibilities?
But it's already there.
It's already there. It's already there, or something else isn't there, right? So, case one. It is already there. So, if array sub hash value, I'm going to make something up right now, is equal to new data structure. We'll just say string. So if it's equal, what should we do? We can either skip it or add it again in the same spot, right? Because sometimes don't you want to like put something back into a hash table with maybe different values? So that would be up to you. So either skip or update, right? And as the designer, you would have to decide which of those you wanted to do, right? Else, now this is where it gets more difficult. Someone already had the answer for this, right? Do a plus plus. Is it empty? If we do a plus plus and it's empty, then what do we do? Put the value there, right? Okay. If it's not empty, what do we do? Plus plus, plus plus. And we have to have some sort of a wrap, so it's wrapping around, right? Right? So we used a mod, so we didn't really have to do a test, right? Okay.
Mod table sign.
So if if we find an empty slot, we go ahead and put it in there, right? All right. So you guys got that? So let's do a get now. Let's do a get array string. Okay? So what's the first thing we got to do? Hash val is out hash, right? So far so good? Do I have to do the same kind of test that I did there? He said yes. So if array some hash value is empty, what do I do then? Just return a null or whatever you're trying to return. Probably it will be a null, right? Else, now what?
If it matches, you want to know if it matches or something else.
Right. So we're not just looking for a slot that's full, right? We're looking for a slot that's full that matches, correct? So then we have to walk the list. This is very scientific. And find a slot that matches. It might be the first slot or it might not be, correct?
Could be the last slot on the list.
Could be. And here again, we got to make sure that we have a mechanism that allows it to wrap. And if you're using a mod, then it's going to wrap. Okay, so that's a linear hash, right? That's pretty easy. And I think we did that. Didn't we do that about 100 years ago? And you guys, we did it in recitation, didn't we? Or we did it here, didn't we?
100 years ago, yes.
Huh?
I said 100 years ago, yes.
100 years ago. That was when my laptop was made 100 years ago. General Patton got it way down the road. Okay, so now we're going to do this for a quadratic hash, right? And it's really not that much different, is it? So we'll start with this. Insert array of a string. My phone does that too. Okay. So we start off the same way, right? Hash val is calc hash string. We need another variable, don't we? What's the other variable we need?
L hash.
For now? We need the value what's this? So we're not just going to use hash value and add 1, are we? So we're going to do plus, first we're going to do plus 0, right? We're going to hope that we get it. Plus 0, plus 1, 4, 9, 16. So we need some sort of value. Let's say the quad value. So we're going to start off at let's see, we can start off at something like this. So while array sub hash val, let's put an if in front of this. Let's say if, this will make it easier for us. Array sub hash val equals null, then return null. That way we don't have to keep testing for that. Okay? That's no way of cheating. While, so we know it's not starting off null. While array sub hash val does not equal null, and array so hash val, something up here, matches string. Wait, we need to say not, right? We're only going to do this while it's not equal, right? So what do we do? Guys, be fussy on these mistakes. Plus quad val, right? I'm squeezing stuff in here.
Erase it.
Oh, I can, yeah. That's what these things are good for, QV. Well, does not equal null. Plus QV. Matches. String.
What is that and?
And not. This is a not. So then we're going to say QV. They have a brilliant idea. If QV equals 0, then QV equals 1. Else QV equals QV plus QV. Yeah. Throw me a lifeline. Let's see what.
QV times QV.
QV times QV. The problem is if it's 1, that won't help really. How about this? How about QV less than or equal to 1? QV plus plus. Does that work? Does that work?
No, because then when it's 1, it goes to 2, right?
Oh, yes. So we want 0, 1. QV.
So what if you start at 1?
So
Instead
we
of
start at 1 here?
Yeah.
Because we're going to miss the very, we're going to miss. So you know, it needs to start at 0.
Make QV equal to QV plus 1 squared.
QV equals QV plus 1 squared. Is that what someone said? Yeah. Does that work?
I think so.
What if QV is 16? That would be 16, 17 squared, right? Let me just have, okay, I'm going to do this, the QV equals 1, then 0, then QV equals 1, else if QV equals 1, then QV equals 4, else, you know, we shouldn't even do
In
this.
the wild, if you have hash val plus QV times QV.
What now?
Hash val plus
QV squared, QV
Yeah.
times
And
QV,
the second QV.
QV. And here all we have to do is plus plus? Oh, that's brilliant. Okay. So, finally we return array hash val plus QV squared. That's all we got to do, right? All right, how about the put? Kind of the same idea, right? Ready for a put? Oh, that was the insert. Get array string. All right, this is the fourth time I've written this. Hash val calc hash string. So far, so good. Okay. QV 0. So what should I do first? Why don't I try this? If array hash val is empty, then return. Okay. While array some hash val plus qv times qv not equal null, and array gets the this qv plus plus. So if we find it, if it doesn't match, we just return, right? HV plus QV. Okay. So I'll just ask you about the chaining. So I won't ask you to do any chaining pseudocode. What?
Oh, yeah, I was gonna ask. So, you won't ask us to do changes?
What now?
You won't ask us to do changes?
I might ask you a question about chaining, just what is it?
But you won't ask us to do pseudocode?
It would just get, it would just get out of.
I'm gonna assume you're gonna be quadratic.
At this point, I might not ask either one.
You might not ask us.
That's the easiest one.
So linear or quadratic, but definitely no chaining. But what is chaining?
Each location will be a list.
An array of
Either a
linked
linked
lists.
list or an array list. So underneath an array list is a linked list anyway. So I think I used an array list just because it was a little bit easier to use. But it really wouldn't matter. And by the way, what happens when your hash table fills up here? So, and how would you increase size? You have some sort of and rehash
large
it.
prime.
And what we say for the quadratic, what was the rule on the hash size to make that all work?
Prime.
Prime,